Hi, I'm Nareen, and I'm the coach of the T-Systems team, the beautiful team you can see up there. They're really excited to show you what they've built, so without further ado, please welcome Sebastian on stage to tell you all about it.
Thank you, Nareen. So the goal of our project was to develop a solution that would support humans, in particular, first responders and technicians at industrial facilities. But what do these professionals have in common? They both need to quickly understand the situation and determine further actions to help a human or to fix a machine. For this, they need instant access to relevant and accurate information. First responders need the vital parameters of a human, and technicians need the sensor measurements of a machine. So, our team developed an application called TRICORDER. TRICORDER can detect smart objects, retrieve real-time data, and visualize information using augmented reality. To do so, we had some major requirements. First, we need to support humans. And for this, we need to create a system in a human-oriented way instead of a technology-oriented way. To make this possible, we had to integrate smart textiles. We use augmented reality to visualize information where and when they are needed. Also, the TRICORDER should be scenario-independent, meaning that it should be able to distinguish between two kinds of smart objects, machines and textiles. And finally, we want to augment our smart objects with interactive elements, such as nodes and instructions. So now we would like to show you how we met those requirements together with our technician, Marco. With his TRICORDER? It's on? Yeah. With his TRICORDER, Marco can get access to the real-time data that facilitates a quick analysis of the situation. The machine records the sensor measurements and stores it in a cloud service provided by T-Systems, from where our TRICORDER fetches its data. As we can see, the TRICORDER detected the machine, and the current sensor measurements are being displayed right on top of the machine. So in case Marco wants to see the historical measurements of one particular sensor, he simply needs to tap the icon of the sensor, and as we can see, for example, the historical measurements of the voltage sensor. But Marco can not only observe the reality, he can also augment it with his TRICORDER. For example, he could leave notes for other technicians. For this, he quickly changes to the notes mode, and then he taps the machine exactly where he wants to leave the note.
Oh man, I'm feeling so tired. The presentations are taking way too much time. I will just leave a note to Sebastian to let him know that I'm not feeling well. What? That I'm not feeling well, but actually I'm gonna take a nap.
Okay, so now this information, together with a snapshot of the current sensor values, is being stored on the server, so that anyone else who scans the machine can see the node. So let's have a look at what Marco just wrote. For this, I'm now also opening my TRICORDER and looking for the machine. Once the TRICORDER detected it, I can now also change the nodes mode, and I can see the node just where Marco left it. So let's have a look. Okay, he says he's not feeling well and he needs to have a nap. But to be honest, that sounds typically like Marco. But luckily, he's wearing a smart textile. So let's go quickly over to him and check if he's really not feeling that well or if he's just pretending. So now I'm moving over to him. And all I need to do is scan the patch on his jacket. And once the TRICORDER detected the patch and retrieved the sensor values from the textile, no? Wait. No? Not really? There it is. So as we can see, it's being displayed right on top of the patch, and as we can see, Marco's temperature seems to be fine. But let's have a look at his heart rate. Maybe that's not okay. So again, all I need to do is scan the patch. Once it's detected, I can see the heart rate being displayed on the patch. So it seems also fine. Well, Marco, it's not looking good for you. But on the other hand, as he's done such a good job with the machine so far, let's nevertheless give him his little break. But before, let's use the triage that is integrated into a smart textile to indicate his condition to others, so nobody needs to worry if they see him just lying around in the factory. For this, I need to tap the triage menu in the upper left corner, and then I can see a set of options that I can set the triage to. As we've seen, Marco is fine, so let's use the green option, and as we can see, the triage is now shining in green, indicating that he's fine. So, while Marco is having a little rest, I'll hand over to my teammate Fodor, who will will tell you how we made it possible to detect the machine and the patches.
Let's take a look at the technical part. At the core of the functionality of the TRICORDER is object detection, because we want to show data exactly there where it belongs. And for that, we need a neural network model that can classify an image and also tell us about the coordinates of the object. So we came up with the following technology stack. We use MobileNet SSD as our base neural network that we train with different images of smart objects using TensorFlow. Then we integrate it with Apple Stack, CoreML, Vision, and ARKit. And now we will show you how this object detection happens in our application. And for that, I will invite CoreML and ARKit. Hi, guys. So first, CoreML gets an image and tries to classify it to tell what is in the picture. She compares it with different objects in her catalog. Once she has found out what is this object, she tries to draw a bounding box around it to tell its coordinates. Once she has found out it, she passes this information to ARKit. Yeah. And he now knows the X and Y coordinates, but the real world is 3D, and ARKit needs to find out the Z coordinate, or how far is the object from the TRICORDER. And for that, he uses heat test. He shoots an array into AR scene to find the point. To find the point at the feet. Great. Now ARKit knows all 3 coordinates, and he can put this bounding box and use it to further augment with different visualizations. Yeah, it fits. Thank you, guys. So, but how do we train our TRICORDER to detect different smart objects? Let's take a look at the TEXTILE. TEXTILE is defined by patches. Patches serve as markers for the TEXTILE. And here things got challenging. Imagine you want to scan a person wearing smart TEXTILE. This can happen in conditions that are way far from ideal. Poor light and textile deformations and so on. Also, we want to differentiate smart objects from many other objects in the real world. So we came up with automated dataset generation for training. We take a picture of the patch and apply our augmentation algorithm that deforms this patch. It adds blur, noise, and perspective deformations. Then we take these deformed pictures and insert them randomly on a huge amount of random pictures. Then, using this dataset, we train our SSD model until it can say what is in the image and where this object is located. So that's how object detection happens in our application. And my colleagues will introduce you to further features of our app. Thank you.
Now let's get back to Marco, who finished his nap and was so kind to return actually to his work shift. So Marco is now again scanning the machine. And as we can see, this time, the TRICORDER shows the critical battery level of the machine. So it sends Marco directly to the repair mode, offering him instructions on how to fix the issue. The TRICORDER not only provides a context-based interface to Marco, it also provides him a workspace in the AR scene where he has access to information that will help him with the maintenance. We call it a workbench. So as we can see, there's an instruction on replacing the battery, but Marco doesn't have a battery with him. However, he has a charger, so he chooses the instruction to charge the battery. And now we can see the workbench offers Marco a video showing him how to perform the instruction. And now, having seen what he's got to do, he takes the battery from the machine and takes it over to his super quick charger to charge it back up again. And now that, now that it's fully charged again, he'll place it back into the machine. Okay, great. So now we're back to our normal mode. As we can see, the TRICORDER shows us normal sensor values for all the sensors of the machine. So Marco can now happily end his checkup. So now you've seen the current status of our TRICORDER. And as you have seen, we've fulfilled all the major requirements that we set for the project. We can detect different smart objects, and we can provide useful information in multiple scenarios using AR to the user of the TRICORDER. In the future, the TRICORDER could be further improved by introducing pose estimation, which will help the TRICORDER to understand the position of the human or the machine being scanned. With this, we could, for example, highlight the part of the human body that needs treatment. Or in case of the machine, we could highlight different parts of it that will help technicians with maintenance or replacement. We also believe that the full potential of the TRICORDER could be achieved by integrating it with a hands-free device, so that first responders and technicians don't need to hold their phone anymore while operating. And with this quick outlook to the future of our TRICORDER, I would like to thank you for your attention, and I would also like to invite you over to our booth at the Magistrale, where you can try the TRICORDER together with the machine and the textile yourselves. Thank you. Now we're looking forward to the feedback and the questions of our customer.
Yeah, thank you very much. I'm very proud of what you have achieved in this short amount of time. And what I would like to ask you, especially for the triage, how far away are we to support first responders with the TRICORDER?
Well, thank you for the question. As you've seen, what we've built is basically a vertical prototype showing all the functionality that we wanted to achieve. But to use it commercially, there still needs to be a lot of work done and improvements done. For example, the detection and visualization of the information needs still to be more reliable, and also to provide any real use for actual first responders, we definitely need to integrate it with a hands-free device, and therefore we also need to wait for the development of the hands-free devices so that they are more broadly used. Thank you.